Okay, this is lesson 9192 video notes, but this is the second video for this lesson. All right, so let's go ahead and start on the front page here. We have a few things that we need to go ahead and incorporate, okay? So one of the things that we're going to be asking you to do today is actually graph a quadratic given just the equation. So yesterday, or in the last video, I taught you about different parts of the graphs and how to look and find things. Now we're actually going to give you an equation, and you're going to come up with all this information on your own, okay? So axis of symmetry is going to be an important guy here when we're trying to figure out how to graph something, okay? It's actually going to be one of the very first things you do is find the axis of symmetry, okay? There is an axis of symmetry formula, okay? And it is x equals... Try that again. X equals negative b over 2a. Now, just kind of a side note here. This comes directly from the quadratic formula. Okay, so think about the quadratic formula here. The opposite of b, plus or minus b squared, minus 4ac, and we're going to take the square root of that, all over 2a. So now, if I look at these guys right here, you will see here is the quadratic here is the axis of symmetry formula, okay? So it's all related, it's all connected together, okay? So your axis of symmetry is going to be negative b over 2a. Now, the next thing we're going to be asking you to find is the vertex, okay? So this is also a really important guy. So when we're finding the vertex, what we're going to do is we're going to take the AOS, so in this case, anytime I say AOS, I'm talking axis of symmetry, okay? So we're going to take the axis of symmetry and plug it into the equation, okay? All right, so those are two probably really important things that we have to be able to find, okay? Axis of symmetry and vertex, okay? Now, one of the other things we are going to find is we are going to be finding the roots or the zeros, and we'll talk here in just a second about how we're going to find those, okay? All right, now I want you to go to this next page here, and what we're going to do is I'm going to give you some steps that we're going to follow, okay? So it says graph each function, identify axis of symmetry, vertex, make a table, and then sketch it, okay? So on the first thing we're going to find here is we are going to find the AOS, or axis of symmetry. And to do that, we're going to use the formula negative b over 2a, okay? All right, so what we're going to do is let's find your first example here. It'll be this guy right here. Okay, so my AOS, or my axis of symmetry. Again, you're going to use the formula x equals negative b over 2a. So in this case, x equals negative b would be negative 6 over 2 times 1. So now negative 6 divided by 2 is negative 3. So our axis of symmetry is going to be x equals negative 3. Now please keep in mind that axis of symmetry, we do expect you to put x equals. It is an equation of a line. So now what I'm going to do is I'm going to come down here to my grid, and at x equals negative 3, I'm going to go ahead and draw my dotted line to show that this is where the center of my parabola is going to be. Okay, we talked yesterday about axis of symmetry would just cut your parabola in half. Okay, now coming back over to this page, let's go ahead and talk about the second step. Okay, so second step, vertex. We need to find the vertex, okay? And this is where we're going to plug axis of symmetry into the equation. Okay? All right, so going back over here. So again, vertex, plug the axis of symmetry into the equation. So coming over here, what I'm going to do now is I'm going to take that negative 3 and I'm just going to be plugging it in up here, okay? So I have got y equals negative 3 squared plus 6 times negative 3 plus 8. Okay, so now go ahead and take a second. Let's type that into your calculator. Okay, and I ended up with negative 1, okay? So y equaled negative 1. Now, when you do this, though, it is a coordinate point. So what did you plug in? You plugged in negative 3. What did you get out? You got out a negative 1. So down here, your vertex is at negative 3, negative 1. Okay? Now this is either going to be your highest or lowest point, but that's the point on your axis symmetry, called the vertex. Okay, now when we're looking at this guy right here, we have a positive 1 here in front. Oops, do positive 1 here in front, okay? If this is positive, if the A value, is positive, it's going to open up. And we'll talk a little bit more about that in a second. Okay, so since A is positive, it's going to open up. Now, to make your table, okay, you're going to make an XY table just like we've done for graphing lines, graphing exponentials. So none of that's changed as far as making a table. But this guy right here, your vertex, okay, this guy right here is going to go in the middle because then we're going to build it out on either side because it's symmetrical. Okay, so we're going to go ahead and put -3, -1 here in our table because that's our coordinate point. Now, the rest of our numbers are dictated off of this guy right here. Okay, so you're going to go 2 above and 2 below on either side of -3. So you're going to plug in, you're going to have a -4 and a -5 on one side, and -2 and a -1 on the other side. And it doesn't really matter if you want to put your -1 up here at top, that's fine. Okay, now when I'm looking at this, I am going to go ahead and I'm just going to plug in -5. And when I plug it in, again, I'm going to just be plugging it into the equation, just like we did for axis symmetry. So I'm going to take this guy right here, and we're going to plug it into the equation. So I've got -5 squared plus 6 times -5 plus 8. All right, so now go ahead and let's type that in your calculator. And I ended up with 3 when I did that. Okay, so I've got 3 here. Now, the nice thing about this is because it's symmetrical. So whatever you have on this side, guess what? You have it on this side at the same place. Okay, so 3 will also be your value for -1. Now, worst comes to worst, you can go ahead and plug this in and make sure that you're getting out a positive 3, but you will. So since it's symmetrical, you only really need to do one of these guys. It doesn't matter which one. Okay, now I'm going to do the same thing for -4. So I'm going to take -4 squared plus 6 times -4 plus 8. Okay, and I'm going to type this in my calculator. And I ended up with 0. Okay, so now again, because it's symmetrical, whatever I have here, I have down here. And we'll put 0 here. All right, so now let's go ahead and graph our points. So -5, 3. So -5, 3. And then my next one was -4, 0. So -4, 0. Then I've got -2, 0, and -1, 3. Okay, so again, it's symmetrical. What I have on this side right here, I also should have on this side right here. Okay, all right, so now let's go ahead and draw your line, or draw your curve here. Okay. And then it says, I'm just trying to see what the directions. So it says, identify axis symmetry, vertex, make a table, sketch. Okay, and then identify the x-intercepts, zeros, roots, or solutions. Okay, so just keep in mind that solutions are where does it cross the x-axis. So this is crossing the x-axis at, if you're looking here, it's crossing right here at -2 and -4. Okay, so those are going to be my solutions. Okay, so I can just tell from looking at the picture on this one. That won't always be the case, but on this guy, we can tell from just the picture. So we ended up with -2, and then x also equals -4. And those are your solutions. Now, if you really wanted to write a coordinate point and say -2, 0, and -4, 0 for the intercepts, that would be fine as well. So either way, you can give me just x equals, or you can give me the coordinate point. Okay, so let's come back over here, talk a little bit more, okay? So we're going to plug in the vertex, okay? Then we're going to make a table, okay? So make a table. Step 4, sorry, find the solutions. Okay, Now, when you find the solutions, important here, okay, you have a couple options. One, look at the graph, which we just did on that last one. Look at the graph. Now, unfortunately, it won't always be a nice, pretty whole number. So it's not always nice and pretty, and it comes up to being decimals and fractions. We'll take a look at an example here in a little bit, but you're either going to have to factor to figure it out or use the quadratic formula. Okay? And then the other thing I'll do, I would tell you just to kind of check. Okay, check direction. Check direction. Okay, so when I'm saying check direction, we're going to be looking at our A values. Okay, look at A value. Okay, if it's positive, it's going to open up. If it's negative, it's going to open down. Okay? All right, so that's kind of a basic overall gist of all the steps that you need to be doing on these, okay? Now, we talked about when we were going through this first example here, we talked, look, if this A value is positive, your parabola should open up, which this is, okay? So that's good stuff. All right, so let's go to the next one here. We're going to look at B. It says y equals x squared plus 1. All right, so now we're starting with our axis symmetry here, negative b over 2a. Okay, so x equals negative b. Well, the problem here is there's no x values in this guy. Okay, x is missing. So my b value is going to be 0 over 2 times 1. So anything divided by 0 is 0. So x equals 0. Okay, now I'm going to go ahead and plug this in and get 0 squared plus 1, right? I'm plugging it into my equation here. And so when I do that, I plug in a 0 and I get out a positive 1. Okay, all right, so now we make our table. Now keep in mind the 0, 1 goes in the middle, right? It should be going into the middle, and then we build it off of whatever this guy right here is. So if he's 0, we're going to go 2 above, so 1, 2, and 2 below, negative 1, negative 2. Now, keeping in mind that these 2 values should get to be the same, and the 1 values should be the same if we do it correctly, okay? So then I'm going to plug this into my equation. So I've got negative 2 squared plus 1. Well, negative 2 squared is 4, plus 1 is 5. So I have a 5 here, and then I'll have a 5 down there. I'm going to do the same thing with negative 1 now. I'm going to go ahead and negative 1 squared is 1, plus 1 is 2. Okay, so just keep in mind, again, symmetrical. Whatever we have on the top and bottom should be the same. The next step in should be the same. And then this guy right here is your vertex, right? So it's going to be your highest or lowest point. Okay, so let's go ahead and do our graph here. So negative 2, 5. 1, 2, 3, negative 2, 5. And then I know it's going to be symmetrical on the other side, so I'm going to go ahead and put that point right across from it over at the positive 2. And then I've got negative 1, 2, and then I know that 1's also going to be a 2, and then 0, 1. Okay, so I'm going to draw my arch going up. Okay, our next step will be to then find where does it cross, like what are our solutions, so where does it cross the x-axis? So if I'm looking at this guy right here, he is never going to touch the x-axis. So if he never touches the x-axis, you're going to get a no solution. Okay, so no solution here. Okay, now just double check, is it going in the right direction? So when I look up here at this guy, my A value was positive 1. If it's positive, it should be shooting up. So yay, we did it right. All right, let's go to the next one here. So axis of symmetry for this guy. Negative b, so negative 10 over 2 times 1. So in this case, x will equal negative 5. Okay, I'm going to go ahead and plug in negative 5 squared plus 10 times negative 5 plus 25. Okay, so now let's undo that. And I ended up with 0. All right, so my coordinate point should be -5, 0. Okay, so let's go ahead and make our table now. So -5, 0. Then you're going to get a -4, a -3, a -6, and a -7. Okay, order's not important in our table, just as long as you get all the correct numbers put in there somewhere. Okay, so now let's go with -3 squared plus 10 times -3 plus 25. So I'm going to go ahead and type that into my calculator. And I end up with 4. So I'm getting 4 here and here. Okay, so now I'm doing the same thing. -4 squared plus 10 times -4 plus 25. So I'm going to type that into my calculator. And I ended up with a 1. So I got 1 here and here. All right, so let's go down graph. So -3. Oh, my axis symmetry is at -5. I should have done that on the last one. 1, 2. So my axis symmetry is at -5, right? Yep. So there's my axis symmetry. Okay, at -5, 0 was my vertex. And then I had 1s on either side. And then 4s on either side. Okay, so I got it opening up. Now, when I take a picture, look at this right here. In this case, I've only got one answer. It's only sitting in one spot. This is called a double root. There's actually 2 points here. It's just they happen to be in the exact same location. Okay, so my solution here is going to be -5 because that's where it's crossing. So back up here, I'm going to get x equals just -5 on this one. And then I'm also going to confirm. Okay, so if I'm looking at this value right here, is that opening up or down? It should be opening up. Okay. All right, let's go to D. Okay, start our axis of symmetry. So we've got negative x equals -5 over 2 times a, which would be -1. So just keep in mind, I'm using the formula -b over 2a. Okay, so now when I do this one in this case, I'm going to end up with a decimal. So I'm at 2.5. Okay, so now when I come down here to do my axis of symmetry, I'm going to put it right in the middle of 2 and 3 at 2.5. Okay, all right, so now I'm going to go ahead and plug in 2.5. Now, guys, when you are plugging this in on your calculator, please, please, please type in this -1 in front. Otherwise, your calculator will not read it correctly. Okay, so when I'm typing this into my calculator, I'm putting -1 times 2.5 squared plus 5 times 2.5 minus 3. So again, I'm just cautioning you right here, please be careful of this, that you need to put a -1 in when you're typing this into your calculator. Otherwise, you will end up with the wrong answers. Okay, and so when I put my calculator, I got 3.25. So my coordinate point right now is 2.5 and 3.25. Okay, all right, I'm going to go ahead and start my table. I've got 2.5. Now, when you are doing your numbers on either side here, go back to whole numbers. Don't use decimals. Don't make it harder than it needs to be. So do 2 and 1 and then 3 and 4. Okay, now keeping in mind though, when you type it in, let's keep that -1 out front so we get the correct answer here. Okay, so I'm going to go ahead and type in 1 here. Okay, and I ended up with 1. So I got 1 for 1 and then 1 for 4. Okay, -1 times 2 squared plus 5 times 2 minus 3. Okay, so again, I'm going to go ahead and type in to my calculator, and I end up with a +3 here. Okay, all right, so I am at 3.25 is my vertex here. So 1, 2, 3. Now the 0.25, just, stick it the best you can. It's just an estimate. Okay, and then I've got 2, 3. Okay, so 2, 3. And then I've got a point on the other side here. And then my next point will be at 1. All right, and then I've got 1, 1. and 4, 1. Okay, so my parabola is opening down. Okay, all right, now we've got a problem though. Your solutions. Clearly this is crossing the x-axis. So what do we do? All right, how do we attack something like that? Okay, so what happens here is it's not always nice, pretty, cut and dry like all of our other 3 problems. In this case, you are getting a decimal answer. So that means you're going to have to actually figure out where do these cross and how do we do that? Well, what you're going to have to do is you are going to have to actually take and use the quadratic or factor it. Now, just to help you out here, you aren't going to find factors of 3 that get you 5. So factoring is kind of out of the question here. So you're going to want to use your quadratic formula down here, okay? So for the solutions, when I can't tell exactly what they are, you are going to have to use the quadratic formula, all right? And then let's see, the opposite of b, so -5 plus or minus 5 squared minus 4. Your a value was -1. And your c value is -3. All divided by 2 times your a value, which is -1. All right, so I'm typing inside my parentheses first. And when I'm typing it in, I am getting x equals -5 plus or minus square root of 13 divided by -2. Now, I'm not worried about exact and approximate and all of that right now. Right now, we need to just get decimal answers. So let's go ahead and take the square root of 13. And we're going to get 3.6 when it's rounded off. So I have -5 plus or minus 3.6 divided by -2. Now let's go ahead and break that up. So -5 plus 3.6 divided by -2. And I ended up with 0.7 for one answer. And then on the other one, I'm going to take -5 minus 3.6 divide by -2. And divide that by 2, and I ended up with 4.3. Okay, so now let's go down and check this on our grid. Does it look right? So, am I crossing right around 0.7? Looks pretty dang good to me. And then 4.3? Yep, looking pretty good to me. Okay, so when it's not nice and pretty in whole numbers, you do need to go ahead and come up with the decimal form of those answers by using the quadratic formula or factoring, okay? All right, so my answers here would be 0.7 and 4.3. Okay, so now when I'm looking at this guy right here, double check. This says it's opening down, right? It's a negative, so just double check. Is your graph opening down? And the answer is yes. Okay, and last problem, and this is a word problem. I know it's going to be a lot, but we can handle it. Okay, so first off, let's review vertical motion formula. Okay, so vertical motion formula, h equals -16t squared plus vt plus c or h sub 0, depending on what website you're looking at. All right, so during the halftime of a basketball game, a slingshot launches a t-shirt at a crowd. A t-shirt is launched from initial upward velocity of 72 feet per second with a slingshot that is 5 feet off the ground. Write an equation for the path of the t-shirt. Okay, so when they're asking you to write an equation, we don't have a finishing height yet. So we're just going to leave h equals -16t squared. My velocity was 72. And my starting height was at 5 feet. Okay, now how long does it take to reach the maximum height? So when you see things, how long, that is your axis of symmetry. Okay, so that's AOS. That's all we're looking for when they're asking for how long to get to the max height. In fact, I'm going to highlight that too because that's kind of important. Max height. Okay, all right, so let's go ahead and figure that out. So we've got -72 over 2 times -16. All right, so negative b over 2a, that's what I'm using here. So I'm getting 72 divided by 32, and I ended up with 2.25 as my axis of symmetry. Okay, so that means at 2.25 seconds before it hits the peak, okay? All right, now next part here. What is the max height? Okay, so when you see things about max height, that is your vertex. Vertex. Okay, And so we know to find the vertex, we're just going to take your axis of symmetry and we're going to plug it in the equation. Okay, so I've got h equals -16 times 2.25 squared plus 72 times 2.25 plus start height of 5. All right, so now let's go ahead and plug that into your calculator. All right, and I got 86 when that happened. So I got height equals 86 feet. Okay, so what this is saying is, right, think about it. 2.25 seconds is when it reaches its max height, and your max height is 86 feet. Okay, our next question here, D, does the velocity of the t-shirt that is shot from a slingshot remain constant? The answer is no. It will change a little bit because of gravity when it's pulling it down. Okay, so no. How many times does a t-shirt hit 86 feet? Well, it should only hit 86 feet one time if that's your top part. All right, it'll only hit that max or minimum one time before it starts to either fall or rise, depending on the problem. How many times does a t-shirt hit 35 feet, assuming it is not caught? Okay, your answer here should be twice. It's going to hit 35 on the way up, and then it's going to hit 35 on the way down if we're getting all the way up to 86. And we'll look at a picture of this here in a second. If the t-shirt were not caught, after how many seconds would the t-shirt return to a height of 5 feet above the court level? Okay, so let's figure this part out. So what I'm going to do first off is let's go down here and let's go ahead and start making a picture. Okay, so we know that our axis symmetry is at 2.5. So I've got 1, 2, 3, 4, 5. Okay, and again, we know the axis symmetry is sitting right there partway through. Now I need to go up to 86 feet. I don't care what you count by. I'm going to count by tens. So 10, 20, 30, 40, 70, 80, 90. Okay, so I know, here's my axis symmetry. 86 feet is the max that this slingshot's going to go. We know from the word problem that our starting height is at 5. Okay, we know that from the information. The initial height was 5. That's what we were told. Okay, so now with that being said, the question is, when does it come back down and remain at 5 feet over here? So that's the question. All right, so if I'm drawing a picture here, I've got it coming up. So there's my slingshot coming up, and then my t-shirt's falling straight back down. But I am going to stop it at 5 feet. And the reason I can do this, guys, is because we know it's symmetrical, right? We know that whatever we have on one side, we're going to have on the same side, as long as our distance is the same. So if I look from here to here, it's 2.5 seconds. And then that means from here to here, it would also be 2.5 seconds. So, excuse me, just make sure that this guy and this guy are the same distance apart, okay? So now the question was, let's go, little guy. There it goes. If the t-shirt's not caught, how many seconds would the t-shirt return to a height of 5 feet? Okay, so if we're looking here, we need to probably go ahead and label. This would be seconds. This would be feet. Slingshot, or you can talk about t-shirt, right? Label all your parts. Okay, but when will it hit 5 feet again? It's going to hit 5 feet at 5 seconds. Okay, so in this case, it wasn't actually asking you to find out where it crosses the x-axis. If it did ask us to figure out where it crossed exactly the x-axis, we would have to use the quadratic formula here on this. All right, and that concludes these notes.